All right, section 12-5, circles in the coordinate plane. So we're going to start off by writing true or false for the following. So the coordinate plane extends without end and has no thickness. Well, that is true. Only lines can be graphed in the coordinate plane. That is false. Any polygon can be plotted in the coordinate plane. That is true. The point 0, 5 and 5, 0 are the same point in the coordinate plane. That's false. The coordinate plane is three-dimensional. That's false. You can find the slope of a line in the coordinate plane. That's true. Okay, so vocabulary, standard form. The standard form of an equation gives information that can help you graph the equation in the coordinate plane. So the standard form of the equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. The standard form of a linear equation is ax plus by equals c. And the standard form of a quadratic equation is y equals ax squared plus bx plus c. All very important, and we're going to use these all. So this is going to be something in this section. This is something you should know. This is something you should know from previous class. All right, so draw a line in column A to a standard form of column B. All right, so if I subtracted 2x, all right, I would get for number 7. So let's do this number 7 over here. So you have y equals 2x plus 3. I'm going to subtract 2x from both sides, and then I'm going to multiply everything by a negative. So I see that this one is this one. Number 8. So I'm going to do the same thing. So we have y equals 3/4 x minus 2. I'm going to subtract by 3/4 x plus y equals -2. And I'm going to multiply the entire equation by the reciprocal, or -4. This to get rid of the fraction, because you can't have fractions in standard form. So this is going to give me 3x minus 4y equals 8. So that would be right there. All right, number 9. We have y equals -x. I'm going to add x, and I get this one. So the last but not least must be right here. All right, theorem 12-16, the equation of a circle. So an equation of a circle with the center h comma k and the radius r is the quantity x minus h squared plus the quantity y minus k squared, which equals r squared. All right, so each point on a circle is the same distance from the center. The equation of a circle with center -1, 0 and radius 6 is this equation. Each point on a circle is r units from the center. The distance formula d equals x2 minus x1 squared equals y2 minus y1 squared. How is the distance formula related to the radius r in a standard equation of a circle? Okay, so the radius is the distance d between center h comma k and x comma y on a circle, and is also the hypotenuse of a right triangle with vertices h comma k, x comma y, and x minus h comma y minus k. So how does distance form the standard form of the equation of circle alike? So the standard form of the equation is the distance formula using x comma y on a circle and the center h comma k, the distance is the radius r of the circle. Okay, so problem 1, write the equation of a circle. So what is the standard equation of a circle with center 3, 5, and radius 6? So the x-coordinate of the center is 3. The y-coordinate of the center is 5. Is this the standard form of the equation? No, it's not. So identify the values of h, k, and r. H is 3, k is 5, and r is 6. Substituting that into the standard equation, x minus 3 squared equals y minus 5 squared, which equals 6. So the only thing we really have to do is simplify the radius. So we have x minus 3 quantity squared plus y minus 5 quantity squared equals 36. And that's it. Okay, so what is the standard form of the equation of a circle with radius 4, 3 that passes through the point negative 1, 1? All right, so if I know the center of the circle and I know it goes through a point, I think I can find the radius. All right, so HK is 4, 3, and we know it goes through the point negative 1, 1. So the radius R is what I need to find the standard form of the standard equation of the circle. So we're going to use the distance formula to find R, then substitute H, K and for R. So step 1 is use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Now we're going to substitute in. Here's the center, and we're going to use the point that's given to me. So we have negative 1, and we have 1. We're going to simplify. We have 5 squared and 2 squared. So we have 25, and we have 4. So we have the square root of 29. Now I'm not going to use a calculator because that's going to come into play real quickly here. Standard form of the equation is x minus h squared plus y minus k squared equals r squared. We know the center is 4, 3, and we know the radius from the previous step is a square root of 29. Now the cool thing is, when I square a square root, it basically just goes away, and there is my answer. All right, problem 3. So let's see if we can graph a circle given this equation. So suppose the equation x minus 7 quantity squared plus y plus 2 quantity squared equals 64 represents the position and transmission range of a cellular tower. What does the center of the circle represent? What does the radius represent? So place a check in the box if the response is correct and an X if it's incorrect. So the transmission range is the same distance all around the cell tower. That's true. The center of the circle represents the position of the cell tower. That's true. The center of the circle represents its transmission range? No. The radius of the circle represents the position of the cell tower. That's false. The radius of the circle represents the transmission range. That's true. So what is the center and radius of the circle with the equation x minus 2 squared plus y minus 3 squared equals 100, and let's graph the circle. So the center is at 2, 3. The radius r squared is 100, so the square root of that is 10. So step 1, we plot the center at 2, 3. Then we count 10 units in all directions. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we go 2, 4, 6, 8, 10. And we go 2, 4, 6, 8, 10. And then we draw a circle through those points as good as we can get it. And there you go. Okay, so suppose you know the center of a circle and the point on the circle. How do you determine the equation of a circle? So do you know the value of h? Yes. Do you know the value of k? Yes. Do you know the value of r? No. So what can you do to find the missing value? You would use the distance formula to find the radius r of the circle. Once you know h, k, and r, how do you determine the equation? So you substitute the values into the standard form or standard equation of a circle. And that's the end of this section.